Hi guys, this is A2 Chemistry, Transition Elements, and we are looking at ligand substitution reaction. Question 1. What is meant by the term ligand as applied to the chemistry of the transition elements? So, a ligand is a molecule or ion. In fact, it can be an anion only, so anion having lone pairs of electrons that form dative covalent bonds with the transition metal ion. So this is the definition of a ligand. Next, describe the type of bonding that occurs between a ligand and a transition metal ion. We've already written it in the definition. Let's rewrite it. Dative covalent bonding, or it is also known as coordinate bonding. Question 2. In general, reactions of the compounds of transition elements can be classified under one or more of the following headings: acid base, ligand exchange, precipitation, and redox. Choose the most suitable heading to describe each of the following reactions by placing a tick in the appropriate column in the table below. Only one tick should be placed against each reaction. So the first reaction has 6 water molecules being replaced by 4 ammonia. So this is a direct example of a ligand exchange reaction. Next, we've got CuH2O6 positive reacting with 4HCl. Whenever we have such a reaction, chloride will replace water molecules, and since ligands are being exchanged, this is also an example of a ligand reaction. Next, FeCl2 forms FeCl3. Here we do not have any ligand exchange taking place. However, we can see that on the reactant side we had an iron ion with a +2 oxidation state because it was bonded to 2 chloride, and on the product side it has a +3 oxidation state, so it is bonded to 3 chloride ions. Therefore, this is an example of a redox reaction. Next, FeH2O6 positive reacting with 2 OH negative ions. We've got FeOH twice forming. Now, iron hydroxide, whether it is iron 2 hydroxide or iron 3 hydroxide, is a precipitate. So, this is an example of a precipitation reaction. And here, since there are 2 hydroxide ions bonded to iron, it is an iron 2 hydroxide, which would be green in color. However, since a base is also involved here, because the OH negative ions are reacting with the soluble iron in the reactant, we can also call this an acid base reaction. But if we are going to call it an acid base reaction, then the question says just one tick is required. So either we place the tick in the acid base column or we place a tick in the precipitation column. We cannot place a tick in both. Next, FeOH twice reacts with oxygen and water, producing FeOH thrice. Here, we only have hydroxide ions as the ligands present, so there is no ligand exchange. We do not have an acid-base reaction taking place because there is no acid or base involved. And we have 2 hydroxide ion in the reactant attached to iron and 3 in the product side, which means the charge on Fe on the reactant side is +2 and +3 on the product side, which means this is an example of a redox reaction. The next equation has CrO3 reacting with HCl. Now, since the reaction is with an acid, we can call this an acid-base reaction. So that is one of the options that can be used for this equation. Also, we have oxygen being replaced by chloride or oxide being replaced by chloride. So we also have ligand substitution taking place here. So this is an example of a ligand substitution as well. So either acid base or ligand substitution would be the correct option for this equation. Next, we've got CrOH H2O thrice, OH thrice plus OH negative. So here we have reaction with a base. So once again, this is an example of an acid-base reaction and also a ligand substitution reaction because one of the water molecules is being replaced by a hydroxide ion. And in the last equation, we have CrOH4 reacting with H2O2 and OH negative to produce CrO4 2 minus and 4H2O. So here we can see that the charge on the chromium ion is plus 3 on the reactant side and plus 6 on the product side. So this is an example of a redox reaction. However, on the reactant side, the ligands present were hydroxide ions, and on the product side, the ligand present are oxide ions. So this is also an example of a ligand exchange reaction. Question 3. Describe the observations you would make when ammonia is added gradually to a solution of copper ions until ammonia is in excess. So we have copper ions present in the form of CuH2O 6 times whole taken and a 2 positive charge in the aqueous state, which on addition of dropwise aqueous ammonia produces the complex CuOH twice H2O 4 times, which on addition of aqueous ammonia in excess would produce the complex CuNH3 4 times H2O twice whole 2 positive, and the color changes would be we start off with a blue solution which is converted into a pale blue precipitate which is further converted into a deep blue solution. So these are the changes that take place upon gradual addition of ammonia until it is in excess, along with the ions that are responsible for the said colors. Question 4. When concentrated HCl is added to a solution of Cu2 plus ions, the solution turns yellow. State the formula of the species responsible for the yellow color and name the type of reaction that has occurred. So, the species that is responsible for the yellow color is CuCl4 2 minus aqueous ions, and the reaction that has occurred is known as a ligand substitution reaction. Ammonia can react as a base or as a ligand. Describe the color change that occurs when ammonia is gradually added with stirring to the yellow solution until ammonia is in excess. Identify the three ions or compounds responsible for the new colors. So we start off with CuCl4 2 minus on addition of ammonia produces CuH2O 6 times 2 positive. On further addition of ammonia produces CuOH twice H2O 4 times. On further addition of ammonia produces CuNH3 4 times, H2O twice, and with a charge of 2 positive. So we have added ammonia in each of these steps. And the color changes are from yellow solution to blue solution to pale blue precipitate to deep blue solution. Question 5. When ammonia is added to the green solution containing NiH2O6 2 positive, gray-green precipitate A is formed. This precipitate dissolves in an excess of ammonia to give a blue-violet solution B. Suggest formula of A and B and write equations for the two reactions producing A and B. So, uh, A would be the ion NiH2O 6 times 2 positive aqueous reacting with hydroxide ions which are produced when ammonia is added dropwise, and this results in replacement of two water molecules with two hydroxide ions. So NiOH twice, H2O 4 times, and this is a solid and this is the solid A. So the color changes are from a green solution to a gray green precipitate. Next, we have formation of B. And here we have added ammonia in excess. So addition of ammonia in excess would mean that NiOH twice H2O 4 times solid reacts with 6 moles of ammonia ligands. Ligand substitution will occur, resulting in the formation of NiNH3 6 times with a 2 positive charge and production of 2 moles of aqueous hydroxide ions and 4 moles of water molecules. So the color changes would be from gray, green, precipitate to a blue, violet solution. So these are the color changes along with the reactions and the complexes responsible for the colors shown. One thing remaining to be shown in reaction A is the two water molecules that were replaced by the two hydroxide ions. So on the product side, we include 2H2O liquid as products. Question 6. P4O6 can act as a ligand. What is meant by the term ligand? It is a molecule or an ion having lone pairs of electrons that form dative covalent bonds with the central transition metal ion. Question 7. The following scheme shows some reactions of Cu2 positive aqueous. So, Cu2 positive aqueous on addition of a few drops of ammonia produces a pale blue precipitate. And they've asked to suggest the formula of each of the following. So, this pale blue precipitate would be CuOH twice, H2O 4 times. Next, we have an excess of ammonia being added to pale blue precipitate A. So if the ammonia is in excess, the solution form would be a deep blue colored solution, which is Cu having 4 ammonia and 2 water molecules as ligands. On the other side, we've got addition of concentrated HCl to aqueous copper 2 plus ions forming solution C, which would be yellow in color, and it would be the ion CuCl4 2 minus. State the color of the following solution. So solution B is a deep blue solution and solution C is a yellow, or you can call it a yellow green solution. Name the type of reaction that occurs when C is heated with copper. So when C is heated with copper, we will have to look at what goes on. So C heated with copper produces CuCl2 with a negative charge, which means the chloride ions having a -2 charge in total and copper having a charge of x gives us a net result of -1. So when the -2 shifts side, it becomes +2. +2 minus 1 gives us a value for x as +1. So in this case, in the case of the reaction with heating of copper, we have Cu2 plus going to Cu positive. So Cu2 plus is converted to Cu plus. So this is reduction. So the name of the reaction is reduction. Next, reduce the role of copper metal in this reaction. So if it is being reduced, reduce the role of copper metal in this reaction. Copper metal is being reduced. So it is an oxidizing agent. No, but in this reaction, so it is converting copper 2 plus to copper. So it is reducing copper. So copper metal itself is a reducing agent because it is reducing the Cu2 plus already present. So Cu2 plus going to Cu in the presence of copper. Okay. So let's put it down this way. Cu2 plus is converted into Cu plus by copper Cu, which has a charge of 0, which itself goes to Cu plus. That means copper metal is being oxidized and copper ions, which are the reactants, are being reduced. Therefore, the copper added is acting as a reducing agent. Question 8. Carbon monoxide reacts with a ruthenium 2 chloride complex according to the equation shown. Describe the type of reaction that is occurring here. So we have a water molecule being replaced by carbon monoxide. So the type of reaction occurring is known as a ligand substitution reaction.